Well, hello everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host. Welcome to our podcast today. Our podcast today is going to be very light, straight to the point. We're going to talk circuit breakers, but we're going to talk the issue between what's the difference between a straight rating and a slash rating. Now, of the two, the slash rating one is the one that offers the most concern when it comes to its installation incorrectly versus a straight. But we're going to look at both of them, and we're going to talk about the National Electrical Code and kind of clarify the applications of the difference between what's something that would be considered a slash rated versus a straight rated in some of their applications. So without further ado, let's jump right into 240.85. If you have a 2017 code, although this didn't change in previous cycles. Okay, so it's still the same area. We're dealing with applications. All right, now, applications for circuit breakers. Let's read it and we'll discuss it. 240.85, the application. And before I even get into that, let's talk about the problematic use. Service trucks, service guys that'll get called out. Usually in the initial installation, people pay a lot of attention to installing the breakers, proper breakers. Everything's done right. An engineer might spec something out, or in your three-phase applications. So not really an issue, but then service people come later and replace a breaker or pop one out, pop one in, or whatever they simply had on the truck, and this becomes a potential hazard. And why is it a hazard? So that's what we're going to look at here, that you just don't pull a circuit breaker off the truck and install it. For example, a circuit breaker, and you're dealing with a three-phase corner-grounded delta system, and you just grab a breaker off the truck that you might also have used in a residential application that is single-phase purely, and you're thinking, well, it fits. And as long as it fits, I'm going to put it in there. That's not the case, and we want to make sure that we keep all of the individuals that do the safety work and that come back and do service, and that they're really looking for these type of things when they're doing their follow-ups and their reviews of systems and the different breakers that are used, because this is frequently violated and it could have consequences that could be liable for the individual that didn't understand the concept. So let's look at it. 240.85 applications. It says a circuit breaker with a straight voltage rating, and when we say straight, we're saying such as a 240 volt or 480 volt, shall be permitted to be applied in a circuit in which the nominal voltage between any two conductors, does not exceed the circuit breaker's voltage rating. So it's a 240 volt or 480 volt application, and between any two phases, it's not going to exceed the voltage that's marked on that straight rated circuit breaker. A 480 volt system, let's say, three-phase breaker, three-pole breaker, 480 volt straight rated, then between any of the two phases, it's going to be 480 volts. Between any of those phases to ground, it's going to be 480 volts. Also, something to remember that in this statement, basically, when you see a straight rated circuit breaker, it is capable of being used in both a grounded and an ungrounded system, which is not the same when we talk about slash ratings. Okay, but when we're dealing with straight rated, just remember that it's 240 volt, 480 volt rated, straight rated circuit breaker. It is capable of between phases not exceeding that voltage level. Between any of those to ground would not exceed those voltage levels. It can be used on a grounded or an ungrounded system. So kind of let that kind of gel in your head a little bit. That's a straight. Purely, there's no slash rating on it. You don't see 120, 240, or 277, 480. It's purely has a 240 or 480 volt. Straight rated application. All right. Now, again, that can be used on evaluated on a system that would be grounded or ungrounded application, wherever that may be. It also goes on to remind us something. It says, you know what? Those are pretty common. Three-phase ones are pretty common to get a straight rated with the three poles. That's pretty common out there. However, when you go down to a two-pole breaker for use in a three-phase application like that, not always so common. So, where it might not be a problem in an application to find it for a normal system, but what happens if we're dealing with a three-phase corner grounded delta circuit where I'm only going to use a two-pole breaker in that application? Now that would be an example where we had a 208. So we might have a delta high leg system where we've got a 240 volt transformer delta high leg where the XO to X2, for example, would be 240 volts. But you have an application where you're going to the neutral connection between the X1 and the neutral, or phase A, to the midpoint of C, would result in what's called a 208 volt, and that would be a high leg voltage. Now, how do we derive that? If you're a math kind of person and you're dealing with a corner grounded delta high leg, then basically you take 240 volts squared minus the 120 volts squared. Then that's going to be 57,600 minus 14,400. That's going to result in a 43,200. And then you take the square root of that, and the square root of that is going to be 207.84. Again, 0.5 major fraction. We're going to round that up to 208 volts. And that's where we get it. Vectorially, it is 1/2 of the delta configuration. Okay, and so it's basically between X1 and XO is going to result in 208 volts. Now, in that application, that means you're adding a two-pole breaker in a configuration where it's going to be in contact with either B and C or B and A, and you would put that two-pole breaker in there. You have to do something uniquely different. And what you have to do is you have to, if that's the scenario, and you got to find a breaker that also has indicated on the front of it one phase / or one phase - three phase. It indicates its suitability to use it in this delta configuration. Okay, so if it's a straight rated 480, 240, that would also equal to a grounded or ungrounded system. But if used on a grounded system, it would be 480 to ground. This would be okay. 240 to ground, it would be okay. That is considered a straight voltage rating. If I'm going to use, and very common to get these in a 3-pole device. But if you get them in a 2-pole device, they are available, that they're more expensive, but you can get them. And as long as you get a 2-pole circuit breaker that's rated in this straight voltage, on the front of it, it will also have a symbol for 1/3-aught, and that would indicate that it's okay to be used with a 3-phase corner grounded delta circuit. That's what you're looking for. I think the problem is people are using this application and they're using the wrong type of circuit breaker for these applications, and that would be a problem, and we need to be aware of that. Now, let's talk about slash-rated breakers. Now, what's the difference? Well, the slash-rated breakers, inevitably, the first thing that you should notice in your mind when you're doing the evaluation here, that there's a slash rating on it. So that means these are to be used on solidly grounded systems only. They're not for ungrounded systems because they have this slash rating on them. They're for use in solidly grounded circuits. All right. Now, it says a circuit breaker with a slash rating such as a 120/240 volt or a 480/277 volt scenario. And I always like to do it the other way. I actually like to say 277/480. That's just a common thing with me, but maybe not the official way to do it. At the end of the day, those are slash ratings. All right. So we have to read what it says here about the use of slash rating. It says, okay, look. Where the circuit breaker is slash rated 120/240 or 480/277, it shall be permitted to be applied in a solidly grounded circuit where the nominal voltage of any conductor, that's any one conductor, to ground does not exceed the lower of the two values. And that's the lower of the two values on either side of the slash mark, if you will, on that breaker. And it says the nominal between any two conductors does not exceed the higher value of the circuit breaker's voltage rating. So between any two phases, say in a 120/240 volt slash rated breaker, any individual conductor to ground, okay, or to the grounded conductor connection inside of your equipment, that connection to the grounded conductor there can exceed 120 volts. And any phase to phase can exceed 240 volts. Now that goes the same way like we said for 277/480. Okay? So the maximum value of voltage to to the solidly grounded connection cannot exceed 277 volts. And the phase-to-phase connections can exceed 480 volts for using that application. All right. So that's the concept that you have to be aware of. For example, I could not use a 120 volt, 240 volt circuit breaker, obviously on a 480 277. Now that's the simplest concept that people should get right, because both the higher level is exceeded with the 480 volt and the lower level 277 exceeds the 120. I mean, that's a common sense approach to it. So let's kind of look at it as a scenario of how this works. So if I had a circuit breaker and that circuit breaker is marked 480 277, then that circuit breaker, because of its slash rating, is not intended for use on a straight 480 volt system, because that system could potentially have 480 volts to ground. That would exceed the lower value of the 277 that's required by the code and what's required by its UL listing. So that would be a problem. And that would be typical with a 480 volt corner grounded delta system. Okay, that would be typical. In that case, I would need to have a circuit breaker that is marked either 480 or it could be 600 volts, because that does exceed the 480 and that would be fine. Now, similarly, what we're talking about for circuit breakers, if the circuit breaker is marked 120 240, then I'm not going to use that on a corner grounded delta 240 volt circuit. I'm just not going to do it, because it potentially could be 240 volts to ground. And again, the slash rating in the code says that the connection that you're making to the grounded conductor in the system cannot exceed 120 volts. And in our case, corner grounded delta, it could be 240 volts to ground. And for a fact, it will. So that would be a problem. So on a 240 volt delta circuit, I'm going to need at least a 240 or 480 or even a 600 volt circuit breaker would be fine for that circuit. Remember, in that slash rated breaker, the lower value is the connection that you can't exceed. That's the voltage to ground. And then the higher value, or that you have of that between the slash ratings, is the measurement from phase to phase that you can't exceed. Okay, so that's what's so service folks, the guys that go out on the truck, just because it fits, you have to be very careful. I could not take an application and use a slash rated breaker and install it on a system just because it would fit, where I'm potentially going to have an issue. I could not take a 120 240 volt, and which is typically listed for use typically in a single phase application, and try to install it on a 3-phase corner grounded delta system in a situation where I'm trying to get a connection between A and B for a 208 application for whatever reason. And I do this, and now it potentially is 208 to ground. That would be a problem. Okay, so the breaker, that the value to ground would be an issue because it exceeds the 120 that's on that slash rated breaker. Just kind of keep that in mind. So the moral of this story is, service folk, when you go out to it, you're looking at the system, identify what the system is, identify whether or not you need a straight or a slash is acceptable in your application that you're dealing with. Dealing with that, understand the voltages that are being associated here, and pick your overcurrent protected device accordingly. Okay. If you don't, you have to remember that these devices were never evaluated. Okay. Because those 2-pole ones that we talked about that have to have that one single phase or 3-phase marking on the front for those corner grounded delta systems to utilize it, these breakers undergo specialized testing. Okay, when they do this testing, each pole individually is evaluated to handle the interruptive capability. That is what's unique about those 2-pole breakers. All right, so understand it, that when it has that one single phase, 3-phase marking on the front of it, that allows you to use that 2-pole device. And again, those are going to be straight rated 240s or 480 devices, and they're going to have this marking on them, and they're okay to use in a corner grounded delta system. All right, but I can't take a breaker that says single phase only on it and try to utilize it just because it fits. That's something that we really have to really be aware of. Okay. Again, a three-pole breaker, for example, are generally available. All right. And they don't utilize a slash marking. You generally get those. A 3-pole, 3-phase usually is going to be in a 240, 480, 270, whatever you get it at. Okay. But 2-pole breakers without that slash marking are truly available if you need it to be utilized on those type of systems. But they're special order. They cost a little more because they take more testing. But if you're dealing with that type of system, you need to be aware of that. And that's important that you understand it. Now, also remember that all of those breakers that are straight rated, that don't have the slash rating on it, that they're internally braced to actually withstand and clear full line-to-line voltage faults. Okay, and these can easily flow through only one pole of the circuit breaker. So and that typically will happen on a corner grounded system. So they're more robust in their evaluation. Okay, they require much more evaluation than you would get something that's usually connected to what's called a grounded neutral system. Okay, so that's the kind of thing that we have to understand. Okay, all right. So that's enough of that for today. Hopefully you got that. It was a quick one, 16 minutes, 20 minutes maximum. If you have any other questions, understanding straight rated versus slash rating and the understanding the use, the key thing that I would take away is if you're dealing in an application that's straight rated, then obviously it's evaluated for a worst case scenario from phase to phase. Okay, or any of those phases to ground. So I can use a straight rated in an application where it might be 120, 208, and it's a straight rated 240, then I might be okay. I'm okay for that application. What I have to be worried about is the ones that are slash rated and I use in that same application where potentially the connection to ground or one of the phases that is connected to ground or the grounded conductor in the system could exceed the lower value of that slash rated breaker. That becomes a problem. It becomes a hazard. It wasn't evaluated for that elevated level of connection to ground, and it could cause the breaker to fail. So be very careful about the ratings. Be very conscious of whether or not you're dealing with a straight rated or slash rated and how you use it. First thing that would go up in my head is if I'm dealing with a system that's 3-phase, is what I'm dealing with. If it's a Y-connected system, then I'm probably not as concerned. I am really concerned with a Delta 3-phase application in high legs and how I apply those breakers and whether or not the breaker is actually listed for single phase and 3-phase, because what I'm doing is I'm deriving a single phase from a 3-phase setup. That breaker has to be identified for that because any of the one poles could take that available issue of interruptive ratings that we have to be concerned about, and that can be an issue that we want to be concerned about because each one of those single individual poles has to be evaluated for its interrupting capacity or its capability, and that's not so different. I mean, that's kind of different than what the ones that are designed to go on a grounded system. And that's what straight rateds are for. Slash rateds are for. They're designed to go on grounded systems. Whereas, again, straight rated can go on grounded or ungrounded systems. Okay? All right. Anyway, enough of that. We're starting to get into circles now. Hey, I want to hope everybody had a wonderful 4th of July. And you spend it with your family. I had my families out here from Virginia. It's a great week. We didn't do anything. It's first time in years we didn't go to the fireworks, but that's okay. We enjoyed being here, watching movies all day, and it was a pretty cool day. So, till next time, folks, stay safe. God bless. Again, visit our website, masterthenec.com or electricalcodeacademy.com. If you listen to our podcasts, if you listen to our YouTube channel is where I kind of put these podcasts as well. Don't forget to give us a thumbs up. I know there's trolls out there who would, but don't worry. We appreciate all the people that listen. So until next time, stay safe and God bless.